Let us see pairs of angles. Now, let us find out the relation between the angles formed when a ray stands on a line. Draw a figure in which a ray stands on a line as shown in the figure 6.6. Name the line as AB and the ray as OC. What are the angles formed at the point O? They are angle AOC, angle BOC, and angle AOB. So on the line AB, you are drawing the ray OC. So you got three angles, that is angle AOC, angle BOC, and angle AOB. So can we write angle AOC plus angle BOC, that is equal to angle AOB? Yes. Why? Refer to adjacent angles in section 6.2. So what is the measure of angle AOB? It is 180 degree because it is a straight angle. So from 1 and 2, you can say that angle AOC plus angle BOC is equal to 180 degree because angle AOC plus angle BOC is nothing but angle AOB, and that is equal to 180 degree. So these two pair of angles make a linear pair. So from the above discussion, we can state that the following axiom. Axiom 6.1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Recall that when the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles. That we have already studied. Linear pair of angles means sum of these angles will be 180 degree. So, when a ray stands on a line, then two adjacent angles so formed will be a linear pair of angles. Now you can see that the axiom 6.1 and that is we just draw adjacent angles of different measures as shown in this figure, and keep the ruler along one of the non-common arms in each case, and does the other non-common arm also lie along the ruler? That is, you're just checking whether the pair of angles so formed will be a linear pair. So you can clearly see that only the angle shown in figure 3, both the non-common arms lie along the ruler, that is points A, O and B lie on the same line and a ray OC stands on it. Also see that angle AOC plus angle COB is equal to 125 degree plus 55 degree 180 degree. So 125 degree plus 55 degree, that is equal to 180 degree. So from this you may conclude that statement A is true. So you can state in the form of an axiom as follows. That is, from these figures only figure 3 forms a linear pair of angles. Thus, axiom 6.2 states that if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Now let us see the proof of this axiom. That is, in the statement above, it is given that two lines intersect each other. So let AB and CD be two lines intersecting at O as shown in the figure. They lead to two pairs of vertically opposite angles, namely angle AOC and angle BOD, and angle AOD and angle BOC. So you got vertically opposite angles, angle AOC and angle BOD. Similarly, angle AOD and angle BOC. Now we need to prove that angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. That I have given by double lines and single line. Now ray OA stands on line CD. Ray OA stands on the line CD. Therefore, angle AOC plus angle AOD will be equal to 180 degree linear pair axiom. You're giving that equation as number 1. Similarly, we can write angle AOD plus angle BOD is equal to 180 degree linear pair axiom. That is given as equation number 2. Angle AOD plus angle BOD, because they form a line. These angles lie on a line, so their sum will be 180 degree. So by linear pair axiom. That is equation number 2. So from equation number 1 and equation number 2, we can write angle AOC plus angle AOD will be equal to angle AOD plus angle BOD. This is because RHS of these two equations were equal, that is equal to 180 degrees. So you can equate the LHS. That's why you got angle AOC plus angle AOD is equal to angle AOD plus angle BOD. This implies that angle AOC is equal to angle BOD. Angle AOC is equal to angle BOD, because angle AOD you can subtract from both sides, or if you take angle AOD to the RHS, then it will become angle AOD minus angle AOD, so that term will be gone. So you will get angle AOC equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC. That is, if we take the other pair of angles and use the linear pair axiom, then you can easily prove that angle AOD is equal to angle BOC. Now let us do some examples based on linear pair axiom and theorem 6.1. So consider the example 1. In figure 6.9, lines PQ and RS intersect each other at the point O. Lines PQ and RS intersect each other at the point O. If angle POR is to angle ROQ is equal to 5:7. That is ratio of angle POR and angle ROQ. POR and angle ROQ ratio is given as 5:7. Find all the angles. You need to find all the 4 angles in this figure. So just the ratio of 2 angles are given. You have to find all the 4 angles in this figure. So let's see the solution. Clearly angle POR plus angle ROQ is equal to 180 degree, because they are linear pair of angles. But angle POR is to angle ROQ is given as 5:7. The ratio is given as 5:7. Therefore, angle POR is equal to 5/12 of 180 degree, that is equal to 75 degree, because total ratio is 5 plus 7, that is 12. So angle POR will be 5/12 of 180 degree. 180 degree means linear pair. So 5/12 of 180 degree is 75 degree. Similarly, angle ROQ will be what? 7/12 of 180 degree, that is equal to 105 degree. The total ratio will be 12. So 7/12 of 180 degree is equal to 105 degree. So you got angle POR and angle ROQ. Now angle POS is equal to angle ROQ, that is equal to 105 degree, because vertically opposite angles are equal. So angle POS will be equal to angle ROQ, that is equal to 105 degree. Similarly, other vertically opposite angles are angle SOQ and angle POR. So they are the other pair of vertically opposite angles, so they will be equal. Therefore, angle SOQ is equal to angle POR, that is equal to 75 degree. So now you got the value of all the angles. Angle POR is 75 degree, angle ROQ is 105 degree. Similarly, angle POS is 105 degree and angle SOQ is also 75 degree.